This was my exhibit at the VCFe Switzerland in November 2025. Alongside Farallon PhoneNet and the 10BASE-2 Ethernet network, I brought the third piece of networking history, Token Ring, the LAN technology most closely associated with IBM and for a time one of Ethernet's most serious competitors. Let's talk about legacy network technology. I'm the vintage collector and these are my stories. Token Ring is often remembered as IBM's alternative to Ethernet, commercially introduced in 1985. But at the time, IBM already had a broad variety of networking technology on hand. Back in 1974, IBM had introduced the Systems Network Architecture, SNA for short. SNA was IBM's proprietary networking architecture for connecting mainframes, terminals, communication controllers and later other systems. In classic IBM environments, terminal networking often meant 3270 terminals and controllers, coaxial cabling and the 3270 data stream protocol. WAN links could be realized over telephone lines using SDLC, the Synchronous Data Link Control Protocol.
The latest development in computer networks is IBM's new Token Ring network system for PCs. What is a Token Ring network, and will it finally set a standard for computer networking?
So when Token Ring was commercially introduced, it became another data link technology that IBM could use underneath its systems network architecture. And needless to say, SNA later also adopted Ethernet in 1988 when the IBM 3745 communication controller was released. But in the mid-1980s, Ethernet was not yet IBM's obvious answer for PC networking. While IBM did release the IBM PC network along with the IBM PCAT on August 14, 1984, this was something entirely different from Ethernet. Like 10BASE-2, it used coaxial cabling, but IBM PC Network used 75 ohm broadband coax, while 10BASE-2 Ethernet used 50 ohm baseband coax. The signaling was different as well, built around analog broadband transmission, while 10BASE-2 used digital baseband transmission, and it was limited to 2 megabits per second. Later on, IBM released a baseband version of the PC network in 1987, which could work over telephone-style modular cabling, somewhat similar in idea to Farallon's PhoneNet for the Macintosh, as we just saw in an earlier episode. But as far as IBM's larger networking architecture was concerned, PC network was not the long-term answer. Token Ring was, and it fit much better into IBM's enterprise networking strategy. The commercial product came from IBM's Zurich Research Laboratory, especially the work of Hans Müller and Werner Buchs, and contributed to what became the formal IEEE 802.5 specification. But the broader idea of token passing networks existed already much earlier. The Cambridge ring, developed at the University of Cambridge from the mid-1970s onward, was one well-known example. It was not the same technology as IBM Token Ring, but it showed the appeal of controlled access on a ring-like local network. There was also earlier patent activity. In 1974, Olof Söderblom filed a patent for a data transmission system that later became relevant for Token Ring networking. The patent was granted in 1981 and IBM licensed Söderblom's patents with the amount sometimes reported as a rumored $5 million or more. Other vendors were affected as well. Bob Metcalfe, co-inventor of Ethernet and co-founder of 3Com, later said that 3Com paid royalties to Söderblom because 3Com sold IBM Token Ring products. But what was all the fuss around Token Ring anyway, and how did it compare to Ethernet? Early Ethernet used CSMA CD, Carrier Sense Multiple Access with Collision Detection. A computer listened to the cable, transmitted when it seemed idle, and if two machines transmitted at the same time, they detected the collision, stopped, sent a jamming signal, waited, and then tried again. Token Ring avoided that collision process entirely by passing a special control frame around the network, the token. Each station received frames from its upstream neighbor and passed them on to the next station. When a station saw a free token, it could capture it, change it into a data frame, add the destination address and payload, and send it around the ring. The frame then traveled from station to station until it reached the destination. The destination copied the data and marked status bits in the frame. The frame then continued around the ring until it returned to the original sender, which removed it from the ring and allowed the free token to circulate again. The rule was very strict: one token, one transmitter. Token Ring also included priority and reservation mechanisms, so some traffic could request higher priority access to the ring. When IBM announced its commercial Token Ring network in October 1985, it offered only a seemingly meager 4 megabits per second. At this point, Ethernet was already offering speeds of 10 megabits per second. The main argument for Token Ring was not raw speed, but predictable network access. And that is where the comparison becomes more interesting. On paper, 10 megabit Ethernet looked like a stronger contender against IBM's 4 megabit Token Ring. But Token Ring defenders argued that raw line speed was not the whole story. On the heavy shared media load, they claimed Token Ring's orderly access method could make a better use of its slower link than the headline number suggested. That claim was not universally accepted. Ethernet advocates disputed the idea that CSMA CD necessarily performed poorly under heavy use, especially in well-designed networks. But we're not here to revisit decades-old networking battlegrounds. What is actually more interesting is the physical cabling system. Despite its name, Token Ring was not necessarily cabled as a visible ring from computer to computer. Depending on the deployment, especially with a single MAU, it looked more like a star topology. With multiple MAUs in place, you could end up with a mixed ring and star topology. But regardless of what the physical cabling looked like from the outside, electrically the signal path still formed a ring. Originally, IBM Token Ring used the 9 connectors on the network cards, together with heavy 150 ohm shielded twisted pair cables and these bulky IBM Data Connectors, often shortened to IDC. Those IDCs were unique in design, built as hermaphroditic connectors that were entirely genderless. Two identical connectors could couple together without needing separate male and female versions. A major advantage of this design was that when the connector was unplugged, internal shorting bars automatically joined the send circuit to the receive circuit to preserve the signal path. Later Token Ring equipment also supported modular connectors and UTP cabling, which made in-house wiring much simpler. In OSI terms, a classic Token Ring Multistation Access Unit, MAU for short, sits at layer 1. It has no awareness of upper OSI layers and simply provides the electrical path for signal transmission. But unlike an Ethernet hub, which is also a layer 1 device, a classic passive MAU like this IBM 8228 does not amplify or regenerate the signal itself. It requires no external power, leaving signal regeneration to the network cards inside the connected computers. Through the course of Token Ring development, there eventually were also fully manageable active MAUs available. A basic MAU, however, is essentially a sequence of relays, one per port. Normally, when nothing is inserted into a port, the relay bypasses that port and passes the electrical signal internally. When a device connects and inserts itself into the ring, the relay changes state, allowing the signal to travel out to the connected station and back into the MAU. And because this kind of MAU does not have standalone power, IBM provided this nifty little tool here. This is the so-called Setup Aid. Basically, it is an IBM Data Connector adapter with a 9-volt battery inside, used to prime the MAU relays when necessary. So far, we have looked at layer 1, the cables, the connectors and MAU, and layer 2, the token passing access method. But that only gives us a working link. The next question is, what did people actually run over Token Ring? This is where the network protocol suites come into play. Today, that usually means TCP/IP. But back in the 1980s, that consolidation had not happened yet. So Token Ring, like Ethernet, could carry a broad variety of protocol stacks and network services besides TCP/IP. From IBM's proprietary systems network architecture SNA to NetBIOS, IPX SPX, Apple Talk, DECnet, Banyan Wines and DLC-based host and printer connectivity. However, for the exploration today, I went with TCP/IP for a simple reason. As I had never used Token Ring in my life, I wanted to spare myself the hassle of also dealing with network protocol suites that are still unfamiliar to me. Going with TCP/IP should make my life easier for now. This way, I can also use this Cisco router to connect the Token Ring segment with my Ethernet network. This lets me also interface those old machines to my existing file servers, which currently run only on TCP/IP. But fear not, I will eventually dive into the alternative protocol suites of the era as well in upcoming episodes. Now, originally I wanted to go with a Cisco 7301 because it has a port adapter slot. However, this router apparently only supports a limited range of PA modules, in particular not the Token Ring ones. So I had to go with the 3700 series router instead, installing this line card here, the NM1FE1R2W. This cryptic name basically means it offers one fast Ethernet and one Token Ring interface and two WIC interfaces for sub-modules. Mind that those are not hot pluggable, so the router must disconnect it from mains when installing the network modules. The Token Ring interface offers both a DE9 and an RJ45 connector, of which only one can be used at a time. I plan to use this router specifically for segregating Ethernet and Token Ring networks. Technically, the two segments could be bridged together, but I will keep it simple for now. Accordingly, I defined two individual DHCP pools for both the Token Ring and Ethernet broadcast domains. And with that, the ring is wired, the Cisco is ready, and TCP/IP should give us a route into the rest of my network. In the next episode, we will find out whether an actual old PC can join the Token Ring, get an IP address and talk to my file servers. And we'll also come back to the question of how to network the IBM PS1 2011. How about you? Did you ever use Token Ring, or did Ethernet already win before you got there? Let me know in the comments below. I'm the Vintage Collector and this was my story for today. Thanks for watching and see you again for part 2 next Sunday.